Hi, I'm Doug from Netmon. In our previous Wireshark videos, I showed you some of the fundamentals of working with Wireshark, capturing traffic and getting around in the Wireshark interface. Today, I'm going to go a little deeper and look at some of the tools you can use within Wireshark to help understand your network traffic at a high level. Here is some traffic I captured from a working local area network with Netmon. The packet list pane shows all of the packets in our capture ordered by time. Before digging into the individual packet details, it's a good idea to get a high-level overview of what's happening in this capture file. Wireshark gives us several tools to do just that. One way to see the big picture is to look at statistical information about the traffic capture. These options are found on the Statistics menu on the menu bar. Let's take a look. The Summary pop-up window shows high-level statistics about the current traffic capture. If we've imported a previously recorded packet capture, the File section will give us some general information about the capture file. The Time section shows us when the traffic was captured and the elapsed time. If the packets were captured using Wireshark, this section of the window will show us the network interface that was monitored and some details about how the traffic was captured. Traffic statistics are down at the bottom of the window. High-level totals and averages shown in terms of packets and in terms of bytes. The Protocol Hierarchy window shows a tree of all the protocols in the capture. The tree is organized to show a protocol hierarchy according to the different levels of encapsulation. In this example, all of the traffic captured is Ethernet traffic, so the fraction of packets in the capture file that are Ethernet is 100%. The Packets column shows the number of packets that match the specified protocol, the percentage of total bytes in the capture that protocol represents, and the bandwidth of the protocol relative to capture time. The last three columns are a little bit different. These columns only count traffic if it is the highest level protocol for a particular packet. All of our Ethernet packets encapsulate higher level packet types, so none of them count towards these statistics. The Conversations menu item brings up a window showing statistics about the different network conversations contained in the packet capture. Every row in the list shows statistics for one conversation, communication between two hosts at different levels of encapsulation layers, this time arranged as tabs. You can filter the packet list based on this conversation so that you only see those packets in the packet list. Prepare a filter for later use, or color the packets in this conversation. Also in this window is the Follow Stream button, which shows a new window containing the raw content of the conversation. You can view this content in a format that reflects the way you'd like to see the data. For example, you can view a text-based protocol like HTTP in the ASCII format. Use the buttons to save or search the stream, or filter out this stream from the packet list. The Endpoints menu item shows a similar window to the Conversation window, showing all of the endpoints or destinations in the packet capture. What an endpoint represents depends on which protocol layer you are looking at. For example, an IP version 4 endpoint is represented by an IP address, but an Ethernet endpoint is represented by an Ethernet MAC address. The Endpoints window is pretty similar to the Conversations window, but it's focused on destinations instead of conversations between two hosts. Finally, the I/O Graph menu item shows a graph of network traffic. You can show up to 5 items on this graph based on traffic filters typed into the filter window or selected from a menu of prepared filters by clicking the Filter button. Only packets passing this filter will be displayed in this particular item's graph color. Once you've got the traffic you want to see on the graph, you can adjust the x-axis values by changing the tick interval, the amount of time each item on the x-axis lasts, the number of pixels per tick, and you can change from time sequence to time of day for the x-axis labels. On the y-axis, you can adjust the unit for the y-axis and the scale for the y units. You can save the currently displayed graph as an image file or copy the values underlying the graph to paste into another application as comma-separated values. Okay, that's our look at the ways you can use Wireshark to gather high-level statistics about a traffic capture. Thanks for watching.